Hi, my name is Mike Scott, Industrial Product Manager for the Modal Shop, and one of our most popular applications for the portable vibration calibrator is proximity probe calibration. Now this video is about mounting the proximity probe, and in this video I'll show you how to take the accessory kit that's supplied with the portable vibration calibrator for proximity probe calibration and turn it into a nice test setup like you see here. It can be a little daunting at first, but once you test your first proximity probe, it becomes quite easy. If you'd like to learn more about testing proximity probes, such as finding cable length errors or creating a calibration certificate, you can visit our website, modalshop.com, click on the Portable Vibration Calibrator homepage, and then click on the eddy current probe or proximity probe calibration page, or visit our video vault as well. Okay, so the first step for mounting the proximity probe is to remove the screws to the top and bottom of the shaker table here, which I've already done, and install your columns. Now, which column to use sort of depends on how much probe is sticking out of the black bracket. We'll get to that in a moment, but the kit comes with various size columns. I'm holding the longest column in my hand, and this is a medium-sized column here that I created by putting two columns together actually, and I'm very comfortable with this size, and I know if I have about 1/4 inch of the probe sticking out of the black bracket that I can use this column here. The other thing you can't forget is to make sure you have the 4140 steel target mounted on top of the shaker, and you don't have to tighten that up with any sort of wrench or anything. Just hand tight is fine because torque is not critical in this application. The next step is to choose the correct mounting bracket. My proximity probe is 1/4 inch in diameter on the case thread, so I want to grab the 3/8 inch black mounting bracket with the 1/4 inch spacer that goes inside of it. So this is actually a little bit more complex. If you had just a 3/8 inch probe, then you wouldn't need the spacer, so it's an extra piece for this particular application, but it's relatively easy. And what you want to do is make sure that extra piece has a crack in it on the one side, and make sure that crack is aligned with the gap in the mounting bracket. If it's not aligned, it's not that big a deal. It just makes it easier to torque the probe down within the bracket. So one thing people always ask is, how much of my probe should be sticking out the bottom of the black bracket? Well, I like to have about 1/4 inch of the probe sticking out the bottom of the bracket, but if you mount it here, not a big deal. If you have even more sticking out, if you mount it this far down or even further, it's not going to affect your test. In that case, I would just need to use a longer standoff for my probe bridge, and you'll see that in a moment, and we can compensate for that. But I know using this column, I want about 1/4 inch of my probe to stick out the bottom of the bracket. Once I feel comfortable with where it is, I can go ahead and tighten this down with my Allen wrench, like so. And now it can't move. And that's the key. The probe cannot move within the bracket. That's the most important thing. Once you have that set up, we'll take the bridge, and this is particularly useful for reverse mount probes. You just go ahead and thread the probe backwards through the bridge, as you see here. I got a little twisted. And then put the black bracket on the bottom of the micrometer barrel. And now the second question you have is, how much of the barrel should stick out? Well, again, it doesn't matter. It's a function of what kind of columns I want to use. Now, I'm very comfortable with putting it on the end of the barrel. Whoop, slipped off there. After I tighten it down, it won't slip off anymore. But I'm pretty comfortable with putting my probe bracket on the end of the barrel and using the columns that you see here on the top of the calibrator. So what I want to do is just loosen that screw a little bit, position my black bracket somewhere on the probe barrel. It really doesn't matter for the purposes of doing a dynamic test. And once I feel comfortable with it, go ahead and tighten that down with the smaller wrench. And now the hard part is complete. This can't move within the assembly. I can go ahead and mount it to the top of the columns. Tighten that down. And we're almost ready to test. If I connect the end of the probe cable to the extension cable you will see an output on my fluke voltmeter here. I have to move a little bit further away from the target, and now I want to set my initial gap voltage at anywhere between -9, -10 volts. -9 means I'm 55 mils away from, or 50 mils, excuse me, away from the target before I start to vibrate that target, which means that the target can move 40 mils in either direction and I can still measure it. -10 volts is another good gap voltage. It's a nice round number, easy to remember, and it means that I'm 55 mils from the target before vibration occurs, and my target can move 35 mils further away from the probe or 55 mils closer, and I can still measure it, which is more than enough in a vibration application. Once you become comfortable with it, as you can see, I set my gap voltage for -10, and at this point I can turn on the shaker and actually start simulating vibration and perform a test. And again, we have other videos for that. I'm going to stop the shaker for a moment. Now I'll just show you, once you set up your first probe, it becomes much easier. If I wish to test the same probe again, all I need to, a similar probe with the same thread, I should say, all I need to do is loosen the probe bracket, remove my probe, put my next probe in, and tighten again. One more time around. There we go. Now it can't move. And I'm ready to test again, and I can use the micrometer to readjust my gap voltage. Now you're probably also wondering, do you even need the fluke meter or the voltmeter here? And it turns out not really, because a great way to cheat is to actually visually see where the probe touches the target, and once it's touching, spin the micrometer twice around. Spinning the micrometer twice around is 50 mils, and you can see I got very close to -10 volts just by doing that. So if you don't have a voltmeter, you can always use the micrometer. 2 times around with micrometer is 50 mils, and that's the correct gap voltage for testing a proximity probe. So as you can see, once you become familiar with the proximity probe adapter kit and your case thread size, mounting the proximity probe becomes fairly easy, and you don't have to worry so much about the position of the probe within the bracket or even the position of the probe on the dial micrometer. Dynamic testing of the proximity probe is fairly simple once you set the proper gap voltage and use the correct mounting bracket. For more information, visit modalshop.com and be sure to visit our proximity probe calibration homepage for those videos about creating calibration certificates and finding cable length errors. Thanks for watching.